All right, everybody. So hopefully you are all in the process of studying and looking over your notes and tests and quizzes for the benchmark tomorrow morning. So essentially a couple things I would do if I was looking over or starting to study or review for this test is I would definitely look back at your tests and quizzes for my class. I know that I've been using a lot of Regents questions, and all the questions on your benchmark tomorrow are Regents questions. So chances are you've probably seen every question that's on your test tomorrow on a test or a quiz. So let's just go through really quickly this first page with all the review stuff. So first thing you have to do is you have to know how to do all factoring methods. Now there might not necessarily be a question that straight up just says factor this expression. It might say which of the following are factored correctly. It might say something where you have to actually factor something to solve for something. But factoring is definitely going to be a key thing on your test. Next, let's talk end behavior. So I know a function is going to look something like this. If the first term is positive coefficient with an odd exponent. I know a graph's going to look like this if it is a negative with an even, if it is a negative with a odd exponent. I know the graph's going to look something like this if it's positive coefficient with an even exponent. And I know the graph's going to look something like this if it's negative coefficient with an even exponent. So for example, like this first graph could be something like y equals 3x to the third plus 7x minus 2. That graph would have that end behavior because the first term is positive and the first term's exponent is odd. Next is odd versus even functions. Odd functions, remember, have point symmetry, where even functions have line symmetry. Also, remember, if I asked you to do this algebraically, you're going to plug in f of negative x. We did that in unit number 2. Division of polynomials, you just have to know how to do that with and without remainders. I would probably say there's 2, maybe even 3 questions on your test tomorrow about that. The remainder theorem says that the remainder of any division is going to come up from whatever you're dividing by. So if I divide p of x by x minus a, I know the remainder is p of a. If the remainder is 0, that means the expression is a factor. Solving equations containing rational expressions, remember you want to make a common denominator and you want to look for undefined values. Solving equations containing radicals, isolate the radical, square for cube both sides, and then solve. Also remember to check all answers. Solving 3x3 systems, we did a lot of that in class. Remember, you can use the matrix on your calculator to check, not solve. So on the test tomorrow, there's going to be one that says solve algebraically. You cannot use the matrix part for that. All right, let's try some practice problems. So the first one says, explain why x minus 4 is a factor of f of x. So to do that, I'm going to evaluate f of positive 4. So I'm going to get 4 cubed minus 6 times 4 squared plus 32. And f of 4 is 0. So because f of 4 is 0, I know it's a factor of fx. If it says explain, I have to say that in words, right? So I'd have to say because f of 4 equals 0, x minus 4 is a factor. Something along those lines. It then asks us to show f of x in factored form. We can do this a couple different ways. Because it doesn't actually ask us to do this algebraically, I could graph f of x and see where it crosses the x-axis. So if I look at the graph of f of x, I see x to the third power, so I know there's potential of 3 factors minus 6x squared plus 32. The graph crosses the x-axis at 4, and it crosses the x-axis at -2. Now when it crosses at 4, it just touches or is tangent to the x-axis, so the graph actually looks like this. So it comes up, back down, touches, and back up. Because at this 4 it just touches, the scale on my graph is totally wrong, but you get the idea. So because it just touches at 4, I know it has an even multiplicity. And since the total multiplicity has to be 3, I know the multiplicity for x equals 4 is 2. So I already know that f of x in factored form is going to be x minus 4 squared times x plus 2. Notice I didn't have to do any division. I didn't really have to do much there other than graph it. Now, if you wanted to do it algebraically, you would have to divide f of x, x cubed minus 6x squared plus 32. You'd have to divide that by the factor that you know, x minus 4. You'll then get something that's factorable, and you can go from there. But I think the graphing method's way easier, especially since you know all about the graphs already. That also helps us identify choice C. It says, what are the zeros? So the zeros are x equals 4 with a multiplicity of 2 and x equals -2. State the end behavior. Well, since the graph looks like this, the end behavior is going to say as the x values get smaller, the function values get smaller as well. As the x values get bigger, the function values get bigger. Sketch graph without using your calculator, that's never going to be asked on a test or a quiz, but it is good for you to be able to do that. So I know it's going to cross at 4, at -2, and I know this is going to come up, touch my y-axis, come back down, and then go back up. I would label this f of x, or just f. And I even know that the y-intercept is going to be 32, because that's the number that ends my function. So that's my answer there. All right, let's move on. So for number 2, I know that the common denominator is x plus 3 times x plus 6. So that first fraction, I'm going to multiply it by x plus 6. The second fraction, I'm going to multiply by x plus 3. And the last fraction, I'm going to multiply by both x plus 3 and x plus 6. Notice I'm not even writing in the denominators because we all know at this point they're going to cancel anyway, so it's a waste of our time. This multiplies out to be 4x squared plus 24x plus 7x plus 21 is equal to 4 times x squared plus 9x plus 18. If I multiply out that 4 on the right-hand side, this line stays the same. Actually, we can combine some like terms here. So if we multiply that 4 out, we get that. I have the same term on both sides, so they're going to cancel. Try and combine your like terms. So if I subtract 31x and subtract 72, I get -51 equals 5x. Divide by 5, and I get x equals -51 over 5, or -10.2. However you want to write it, doesn't really matter. Right? Fractions are our friends. For b, if I square both sides right away, I get x plus 1 squared equals 2x plus 5. X plus 1 squared, we've done probably about 20 times already, so I'm hoping that you know what that's going to look like by now. Same term on both sides cancel. Subtract the 5 so we can try and factor. And I have x squared minus 4 equals 0. Factors of that are going to be x plus 2, x minus 2, which give us answers of 2 and negative 2. I have them in the wrong spot. Look at that. Negative 2 and 2. Now, if we solve by checking, you'll notice that negative 2 cancels, and that's your answer. Now, if you check this, you can check this graphically, meaning you can graph it and see that we have a graph that looks like this, and see where they intersect, like we did in class. Or you could plug them in the calculator, either way. Number 3 is already kind of set up. You don't have to multiply by anything. Remember, you're looking to try and eliminate a variable where either the numbers are all the same or some of them have different signs. So if these a's were not all 2, I'd multiply whatever to make them all the same number. So I'm going to add the first equation to the second equation. And I'm going to add the last equation, because I didn't use that one yet, to the middle equation. Now, these two equations I just came up with, I have to solve as well. Unfortunately, neither of them have a common term. So I have to multiply them so that something comes out to be a common term here. So if I try and eliminate, say, the b's. If I try and eliminate the b's, well, I would multiply the first one here by 13, and the second one here by negative 9. The reason why I'm making it negative is so that we get something there that will cancel. So if I do 13 times 9, I get 117b. Plus 117c equals 135 times 13, so that's 1755. For the second equation, I'm going to get 117b, but negative. I'm going to get negative 72c, and I'm going to get negative 1350. These cancel. 117 minus 72 gives us 45c. 1755 minus 1350 gives us 405. Divide both sides by 45, and I get c is equal to 9. Once I know c is 9, I can plug it back in to figure out what b is. So I can say 9b plus 9c, but c is really 9, equals 135. And if I solve that, I see that b is equal to 6. I'm hoping you can all solve that. Once I know b is equal to 6, I can then say, well, 2a plus 3 times b, which we know is 6, plus 4 times c, which we know is 9, is equal to 60. I can choose any of the 3 original equations. It doesn't matter. And then if you solve that for a, whoa. If you solve that for a, you get a is equal to 3. All of this you could check by making a matrix on your calculator. Factoring, the first one is the AC method. That gives us 60. What multiplies to make negative 60, but adds to make 7. I know that's going to be, what, 60 to make 7, 12, and 5. So I'll do plus 12x minus 5x minus 30. First two terms have a GCF of 2x, so that leaves us with x plus 6. Second two have a GCF of negative 5, leaving us with x plus 6. So now I'm left with x plus 6 equals 2x minus 5 as my two factors. Now again, this might not be a question where it says factor this expression, but it might be part of a bigger problem that you have to factor. 3x squared, leaving us with x minus 2, negative 12, leaving us with x minus 2. So I wind up having 3x squared minus 12 and x minus 2 as two factors, but I notice there's still a GCF there of 3, x squared minus 4, x minus 2. Holy smokes, there's still something to factor. So I can make that x plus 2, x minus 2, x minus 2. C, x cubed plus 27, I know is difference of two cubes. So I'm going to make that x plus 3, x squared, and then minus, I'm using SOAP. Multiply the 3 and the x together, 3x. And the last term is always positive, and it's whatever 3 squared is, AP. So where I'm getting all this from is what multiplies by itself 3 times to make x cubed, that's x, that goes in the first spot. What multiplies by itself 3 times to make 27, well that's 3, that goes in the second spot. Then to make the trinomial, you're just going to square the first number, multiply the two numbers together, and then square the last number. I could use the same concept for D, so I'd make this 5 minus 2a, square the first number, opposite sign, multiply the two together, always positive, square the last term, and I'm done. That's your review in a nutshell. Obviously this video is not nearly enough to be able to do everything on your test tomorrow. So you really have to look back, review other concepts and other things that we've done in class. Hopefully you've been all doing that. All right. Best of luck with your studying, and I'll see you all in the morning.